Today we are learning lesson 9.1 on circles and parabolas. We will cover a little more than half this lesson, and the next day we get on to chapter 9 when we'll finish the rest of it. So before we start 9.1, talking about in general what chapter 9 entails is conic sections. Conic sections is again basically cross sections of a plane and a double nap cone, right? Or cross section of the double nap cone. We have a picture in our book that you can look at. It doesn't scan in very well, but basically our options that we're going to learn in this chapter are circle. If we kind of put the plane through the cone, either of them is parallel to kind of our cone's base, and we'll get a circle. If we slant it, we'll get an ellipse, which some people will call an oval. We can push it through the on this top one over here, we can have it go at an angle so that we're ending up with a parabola-like shape. And then lastly, we can have it straight up and down, kind of, so that we're going to get both a piece on the top and on the bottom. So starting off with circle, right? Circle is a set of all points x, y in a plane that are equidistant from a fixed point, which is hk, which is the center of the circle, right? The distance between the center and any point on the circle is the radius, right? Nothing new there. We've learned that in geometry, that, right, distance from any point on the center to the outside, any point on the outside to the center is going to be constant for it to be a circle, right? Talking about hk, that is our center. Here's a form that involves hk, right? Standard equation is going to be x minus h squared plus y minus k squared equals r squared, where r is the radius, hk is the center, and so the center is at the origin 0, 0. Clearly, then it's just going to be straight across. X squared plus y squared is 4, or r squared. So r squared could be a number like 4, 9, 16. It doesn't have to be a perfect square. So moving on. Sketch the circle, identify its center and radius. And so, again, putting this right up against its standard form, right, of x minus h squared plus y minus k squared is r squared. We can see that h is 2, k is the opposite of plus 4, so minus 4. So basically, we're flipping our sign to each position, and then we've got r squared is 16. And when you square root, we get r is 4. So we have a radius of 4, center is at 2 minus 4, so graphing is pretty quick. 1, 2, 1, 2, 3, 4. Graphing our center right there. And in general terms, I typically do 4 key points. So we're going to move 4 to the right. There's 1 point on the radius, and then go back to the middle, on the circle. And then moving radius up, 1, 2, 3, 4, will be on the x-axis there, right? 4 up, back to the center, 1, 2, 3, 4, radius to the left, and then back to the center, 4 down, and then making a slow curved line through these points will typically give you the circle appearance. So that's not too bad for mine, not quite perfect, but general idea speaking, then you're going to go through those 4 key points in a slow curved manner. Moving on to the next part, we have write the circle in standard form. So now we're going to have our complete the square skills tested again, as it happened in the past. And so what we're doing here is taking the pieces they give us and completing the square. Right? So how complete the square works is a reminder of x squared minus 6x plus some number that will make this a perfect square. And whatever number that goes in there, we're going to add that to the outside. So to the side that has 0, we're going to add our blank to that side. So whatever we do to one side, we're doing to the other. And to make it a perfect square, right, we're going to divide this -6 by 2. So half of -6 is -3. And when you square that, -3 times -3 is 9. It will always be a positive number. That's why I do with a plus. And so we're adding 9 to both sides. Next, we need to do the same process with the y squared plus 6y plus blank to both sides. And now I kind of ran out of space for my 14, so we're going to actually bring the minus 14 from the original equation over there. Right? So, and now completing the square on this side, we've got half of 6, which is 3. 3 squared will be again 9, and we're adding 9 again. Right? So I have 2 different blanks, one for the y, complete the square, one for the x, complete the square. And now when we factor this, right, we already have what the value is going to be right there. That's x minus 3 squared. Right? You could also relook at x squared minus 6x plus 9. How's it going to factor? And you'll get the same answer. Minus 3 times minus 3 is 9. And minus 3 plus minus 3 is minus 6. Right? Same thing goes for here. This 6 divided by 2 gives us what we would call our b value, or in this case, minus k. But we've got 6 divided by 2 is 3. That's where the plus 3 comes from. And then doing the math over here, I've got 18 minus 14. That's going to give us 4. And there is our completed standard form. Right? Okay. Notice a little note on the last question. I feel like I didn't emphasize enough. I talked about it. It did ask for the center and the radius, so make sure you circle and label those as part of your answer. Moving on to one more version of this, we've got, given the center is 6 minus 3, a point on the circle is minus 2, 4. A couple different ways you can do this. Again, just using the definition. If you think about it just for a second, the definition, right, that we're going to have some point 6 minus 3, and then negative 2, 4 is going to be on the circle, right? We can find the distance there and use distance formula, or simply rewrite what we have in the x minus h squared plus y minus k squared equals radius squared. Plug everything we know in, and that will help us solve for radius squared. But we don't really need r, we just need radius squared. So plugging it in, I got x minus 6, because h is 6 there, squared, plus y minus a negative 3 is going to be plus 3 squared. Just again, a reminder, with minus a negative 3 is r squared. And then we haven't used this point yet. This is an x and a y value, so we're going to plug it in. Negative 2 minus 6 squared plus 4 plus 3 squared equals r squared. And so now we're just completing the math. I've got 7 over there, minus 8 here. And when we square it, 64 plus 49 is going to give us 113, and that is r squared. And so now I'm just going to rewrite this first equation with r squared built in. X minus 6 squared plus y plus 3 squared equals 113. Okay. Moving on to parabolas. We'll do a couple parabola problems, and then we'll reach our stopping point. Okay, a parabola is a set of all points in a plane that are equidistant from a fixed line and the directrix. So, differently than the first chapter we went over parabolas, right? In conic sections, they're saying the focus being a fixed point and this directrix being a line, the distance from any point on the parabola, like again they show a point here, this distance d1 from the focus to the point on the parabola is equal to the same distance d1 from the directrix. Right, so our equation is going to look a little different when we're using these. Now notice between the focus and directrix, right, if you're looking at it, right, this distance here is equal to this distance here. We'll call it something different. We'll call it actually P. That's the letter we'll use for it. Right, the distance between the focus and vertex is P, and between the vertex and directrix is also P. Now from the vertex, that's our typical key point, we'd be adding P to whichever direction the movement's going to find our focus. We'd be subtracting P to find the directrix from that point. Okay. Again, just reading through here, focus and directrix of the vertex. Midpoint between them is the vertex, right? The midpoint between the focus and directrix is the vertex. Hence the P, right? That pattern. Moving further on, right? The directrix is vertical or horizontal line outside the parabola. Now, no, didn't make a mistake there. We are actually covering both up and down parabolas and left and right parabolas. Okay. Right. So those are the types of graphs we'll be doing, because we're not only dealing with y equals the number of x squared, but we'll be dealing with x equals y squared. Next, the focus, right? That was that point inside the parabola, whereas the directrix was the one outside. So say our parabola is moving and opening to the right, our directrix would be on the left. Like in this picture here, if we're moving to the right, our directrix would be here, the focus is inside. If we're moving to the left, right, our focus is on the other side, directrix is on the other side, the dotted line. Focus is a point on the inside. And so on over here, right? Inside if we're going up, and underneath if we're going down. Next, vertex is the midpoint between the focus and directrix. It is also our extrema. It's our relative max. Sorry, it's actually our maximum or minimum, not relative. Axes is which way we're opening, vertical or horizontal line made by the focus and the vertex, and it's perpendicular to the directrix. Meaning if we were going up and down with our graph, right, our axis would be this line up and down here, which would be perpendicular to wherever the directrix would be. Okay. Now comes the equations. Okay, this is why we use the value p. X minus h squared equals 4p times y minus k. And again, p cannot equal 0. P was 0, we would have x squared isn't 0, right? We wouldn't have a number of y, right? So p will never be 0. X minus h squared equals 4p y minus k. Now that is when we are opening up or down. The first question would typically be, well, how do you know which way we're opening? The p value is actually the decider in it, right? Back when it was y equals x squared, it was a that decided that. If a was positive, we opened up. If it was negative, we're going down. So looking at the equation here, right now we have a number of y, right here, a number of y equals x squared, right? Y equals x squared, the general idea. And so p is going to be that coefficient that decides if we're opening up or down. Now again, if we find our center here, that's our vertex, our hk, right? We have a number outside the y minus k, then we're going to divide by 4, and that will be how much we move from the vertex to get to our focus. Right, so looking down at these pictures here, that's what it's talking about. If we have the equation of x minus h squared equals 4p y minus k, we're opening up or down. If p is positive, that's what p greater than 0 means. We're going to be going up, right? If p is negative, less than 0. Now in the second picture, we're going down. Notice the equation didn't change, still the same. But over here, now they switch spots. When we've got y squared equals x, we're opening left or right. Opening in a positive way for y squared is going to be opening to the right. Like going to the right is positive for x, going up is positive for y. So typically how I say this is if we have like y equals x squared, that means we're going in the y direction, up or down. X equals y squared, we're going in the x direction, which sounds a little opposite, but that's actually how it works. And lastly, y minus k squared equals 4p x minus h, right? And if p is negative there, we're going to the left. So again, just a little reminder, the focus down here, horizontal directrix is, again, your center, hk, and this is when we're going up and down, right? This is the x, x squared is y, moving up and down, right? We're adding p to that y value, right? The focus is going to be somewhere on the inside. If it's going, if our directrix is vertical, so we're going like this, and our graph is going either to the left or the right. So from our vertex, we're moving p direction to get to this focus point, which again, we're adding to our x value. So let's get a problem or two in. So we've got 3x squared plus 2y is 0. Okay, so solve for y, x squared, right? Because our standard form, x minus h squared equals 4p y minus k. Now we won't have a lot for h and k at start, but we'll move into that as we go. So here 3x squared equals plus 2y is 0. Subtract 2y from each side, we get 3x squared equals minus 2y, and then we need to divide by 3. All the values should be or coefficient should be along over there. So standard form, x squared equals minus 2/3 y. And that is basically our standard form. I don't see an h or k. We have a parentheses here with some values. If we have that, so our vertex is actually 0, 0, or our center. So there we already are on the graph, 0, 0. X squared is y, means we're moving in the y direction, which would be up or down. And now to decide what p is, we set 4p equal to this coefficient of negative 2/3. Now we've done this in the past when we have a variable, number of variable equals a fraction. Instead of dividing by 4, I'll choose to multiply by 1/4, which is the same thing. However, it is just the version that works best for finding out what p equals in this case. So p equals negative 2/12, and we simplify to get negative 1/6. Now, that means the distance between this center that we already have, this vertex, and p is negative 1/6. Now, to make that even look like anything, I am going to say that our scale on this graph is 3 blocks is 1. So right there, that would be negative 1, the blue little dash I wrote. And so p equals minus 6 would mean from this center, we're going down 1/6, which if 3 is 1, that is going to be half, right? So even making that 3 times scale, just going that little bit, there is my focus right there. Now going the other direction of 1/6, there is my directrix. Attempted at a straight line in dotted line, right? And so what is that, right? That is y equals 1/6, right? We went up 1/6. And so our graph is just going to be, we don't pick other key points on this one, but the keys that I want you to graph are the vertex, and then the focus and directrix being graphed. So again, as a reminder, what was our point? Our vertex was 0, 0. And then because we were moving up or down, we were adding to this, we're adding p to our y value, and our focus is going to be 0 and adding to 0. Our p value is negative 1/6. And then going the other way, right now technically our directrix is not going to be a point, but just as the idea, if we go the other way, we'll have 0, 1/6. It's a line though, so that is y equals 1/6, as previously stated. So filling that in up top here, we've got y equals 1/6, and the focus is a point 0, negative 1/6. Last one we're going to do here is 2x plus y squared is 0. Again, solving for x actually. So we got y squared equals minus 2x, and that's actually standard form, right? So this is going to be a standard form where we're going left or right. And again, I don't see an h or k. We don't have a parentheses here, so my vertex is 0, 0. Right? Graphing it again. Now, because we have x equals y squared, we're moving in the x direction. So this one will open left or right, and when we solve for p, right, 4p equals negative 2, divide by 4 on both sides to get p equals negative half, right? That says we're opening to the left, because when you think about x's, right, moving to the right is positive, moving to the left is negative. So in this case, our graph is going to be something like this already. But let's graph the focus and the directrix, right? So negative half from my point. Since I have colors, I'm going to choose purple here for this time. That my focus is right there, half in. And again, from 0, 0, we're moving half in the negative half in the x direction. So my focus is negative half, 0. My directrix is going to be x equals positive half, because it's going to move half in the other direction. And completing my no more dotted line graph, and just fill it in here. And there is my graph for y squared is minus 2x.